Now, chain rule is used to differentiate composite functions. An example of a composite function is y is equals to 3x plus 1 squared. Now, one way in which we can be able to differentiate this function is by expanding 3x plus 1 squared and then differentiating the resulting function term by term. Now, if you expand 3x plus 1 squared by foiling, we shall end up with y being equal to um, 9x squared plus 6x plus 1. And therefore, if we differentiate the resulting function, we shall end up with 18x plus 6. So that's one way in which you can be able to differentiate this function. Now, an alternative approach is to use substitution. So we can let u to be equal to 3x plus 1. So here we'll have y being equal to u squared. So basically, chain rule states that if y is a function of u and u is a function of x, then dy over dx will be equal to dy over du multiplied by d over dx. And I'm going to explain what that means here. So let's start from the very beginning. So we said let u be equal to 3x plus 1. So here you can see that the variable is x and u is a function of x. So you can be able to differentiate this function with respect to x. So we'll end up with du over dx being equal to 3. And then because we've substituted 3x plus 1 with u, that means that y will be equal to u squared. And therefore, this is a function in terms of u. Basically, y is a function of u. So we can differentiate with respect to u. So dy over du will be equal to 2u. And then we can combine these two guys using this rule. So basically, we shall end up with dy over dx being equal to dy over du, which is 2u, multiplied by du over dx, which is 3. But of course, we know that u is equal to 3x plus 1. So you can substitute that back. So we'll end up with 2 into 3x plus 1 multiplied by 3, which can be simplified to 6 into 3x plus 1, and therefore being equal to 18x plus 6. And you can see that's similar to what we have here. So that's an alternative way on how you can differentiate this function. Another way, which is very similar to the second approach, is by again working out chain rule mentally. Remember, we said that chain rule is used to differentiate composite functions. So a composite function is a function where you have one function inside another function. So in this case, f of x is it's a function that's inside g. So g takes the results of f of x, and therefore we have a composite function. So basically, if you want to differentiate this function, one way to do it is you differentiate the outside function, which is g, and then the inside function, which is f. I know that sounds confusing, but basically this is what it means here. Now, if you look at what we had originally, y is equal to 3x plus 1 squared. Now, the inside function here is 3x plus 1. Yeah, so basically, if you want to find dy over dx, in this case, we differentiate outside. So the inside, which is 3x plus 1, we assume it's just a variable. Like in the previous case, we assumed that was u. So we assume it's a variable. So we differentiate the outside. This is what it means. So outside and then inside. So basically, we differentiate the outside, so we ignore the highlighted part. We just differentiate the outside, and using power rule, we'll end up with you bring the 2 in front, assume this is just a variable. So 2 into 3x plus 1, you don't touch the inside, and then reduce the power by 1. And then now we differentiate the inside. Now the inside is 3x plus 1. Again, by power rule, if we differentiate that, that will be equal to 3. And then you just finish it off. So that will be 6 into 3x plus 1, which will be equal to 18x plus 6. Yeah, and you can see in each case we end up with the same result. So depending on the nature of the question, chain rule applies especially if you have a composite function. You can have different types of composite functions, as we'll discover later on. Okay, so moving on, let's try and apply these methods in these questions. So I'll start with number 1. So basically, I'll apply this method here. Um, so that will be the inside, and of course the outside will be something to power 5. So dy over dx will be equal to outside, so you'll have 5 into 3x minus 1. Of course the power reduces by 1. And then inside, differentiate inside, that will be 3. And therefore we end up with 15 into 3x minus 1 to power 4. And that will be the required solution. Again, this is basically chain rule, but now we are trying to work it out mentally. The second part, again, you just need to identify what's inside. So that's basically, or what you could have substituted in place of u. So basically you have the inside, and then dy over dx will be equal to outside. So you have 7 in front, 1 minus 3x to power 6, because the power reduces by 1, and then inside negative 3. So you end up with negative 21 into 1 minus 3x to power 6. That's it. Again, same approach can be applied in the next question. And basically in the next question, you can rewrite it such that this will appear this way. So y will be equal to 3x squared minus 4 to power a half. And therefore, dy over dx will be equal to a half into 3x squared minus 4. And then a half minus 1, that will be negative a half. And therefore, that is the outside. Remember, we started with the outside. This is the inside here. Okay. And then you proceed to the inside. So the inside, if you differentiate 3x squared, that will be 6x. And then what you can do in this case is just to simplify the resulting expression. So a half of 6 is 3. So this will be 3x into 3x squared minus 4 to power negative a half. And that will be a derivative.